All right, welcome back to Jedi Lessons, week 6B. Today, we are going to be working with a Ferris wheel. So let's make our little Ferris wheel really quick. Big guy, got some seats. Seat. We got seats all around it. The Ferris wheel rotates at an angular velocity of 0.24 radians per second. Starting from rest, it reaches its operating speed with an average angular acceleration of 0.022 radians per second. How long does it take for the wheel to come up to its operating speed? We're working with a few things here. We're working with our angular velocity. We're working our initial velocity. And then we're working with our final velocity. Final. We're also working with acceleration. That's a big one. And time. So we're ultimately trying to figure out what time is. We have been given a couple things. First, we were given the initial velocity at rest. Now, if you think of at rest, I think of not moving. So I would think that that equals 0 radians per second. Its final velocity, I would say, is 0.24 radians per second. And its acceleration is 0.022 radians per second squared. We were given that earlier. So, we are going to put in our equation, which this is an equation from a long time ago, but it's just using different variables now that we're using angular kinematics. So we're going to be doing velocity of our final equals the initial velocity plus acceleration times time. We have a few of those numbers. We have our final velocity, we have our initial velocity, we have our acceleration, but we don't have time. So since we don't have time, we need to find out a way to isolate it. All right, simple. V of f, all right, we have that. V I mean, that equals 0, so like there's no point of having it in here. So we can do VF AT. That would make it simple, and then we can figure it out. We need to isolate time onto one side of the equation, or on the equal sign. So in order to do that, we're going to divide both sides by our acceleration. So now that we have time equaling our final velocity over our acceleration, we can figure out how long it's going to take for the Ferris wheel to come up to its operating speed at 0.22. Or with the acceleration of 0.22, its final operating speed of 0.24 radians per second. So we're going to have time equaling 0.24 radians per second over 0.022 radians per second squared. And if we look at this, we're going to look at our units first, just to see if there's anything to cancel out. And since there is, we have radians per second, and we have 2 of these radians per second. So, I mean, looks to me that we can cancel the radians per second. And since seconds is squared, we're just going to have an s left over. Now that we have our units situated and our final answer is going to be in seconds, we are going to do our math. And if we do our math really quick, we're going to do 0.24 divided by, shows right there, 0.022. That equals 10.909090901. So 10.909 seconds. We can reduce that down, make it a simpler number to 11 seconds. And that is how long it will take for our Ferris wheel to start at an initial velocity of 0, so not moving at all, in order for it to get all the way up to its top speed of 0.24 radians per second.